Okay, I think we can start. Let's see, we have about 20 participants. Okay, so welcome back all to OWASP TimeGap 2020. My name is Nissim, and before we start, I would like to cover a couple of points. First, this session is being recorded. It will be shared on OWASP Israel YouTube channel. The slides will be shared on the OWASP Israel website itself. We'll have about 5 to 10 minutes for Q&A at the end of the session, so feel free to drop any question on the chat. And before we start, I would like to thank the gold sponsors, both Amdocs and Checkmarks. Link to their website can be found on the AppSec.il website. Today, we are pleased to welcome a very special guest, Mr. Abhi Balakrishnan. Abhi is a security consultant working for Security Compass, San Francisco. He has produced several open source projects in the last few years. Abhi is here today to talk about one of his latest projects called OWASP TimeGap. So good morning, Abhi. It's all yours.
Thank you. Thank you, Nathan. Have you started the recording?
Yes, we're live.
Okay, thanks. Hey, first of all, thanks to everyone for joining. We are premiering TimeGap Theory. This is our first launch, and we are premiering in parallel sessions. At the same time as AppSec Israel, we are launching it in OWASP Global AppSec as well. So this is not out to the world yet. You are one of the few people who gets a chance to see what this project is about and what it is, and what these issues and everything firsthand. So I'll be talking about OWASP TimeGap Theory. I'll be talking about TOCTOU issues. What is a TOCTOU issue? What are risk conditions? We will see them in the next couple of slides. You already got an introduction about me from Nissim, so I'm skipping this particular slide. This is going to be our plan today. I'll give you the story behind OWASP TimeGap Theory. Why did we came up with this project, and what was the thought process behind it and everything. I'll introduce the project to you. We'll walk you through some of the challenges. So when I walk you through that, you will learn a few of the tools and techniques to find and exploit TOCTOU issues or risk conditions in web applications. I'll also share some tips and tricks with you. If we have time, I will share some interesting stories about TOCTOU. Then I'll share the links so that you can learn more once after the session. By the time we complete, you will be a TOCTOU champion. This I can promise. So let me talk about why we came up with this project. So my day-to-day job involves sitting in threat modeling sessions, looking at software architecture designs and saying, hey, this is a security issue that can bite us later. Maybe we want to have these type of controls, and these are the best controls that are that we can think of. But like if you want to cut short the time and effort, and these are the things you can do. Those type of things. So I was in such a session, and I was like, once I saw a software design, and I was like, hey, looks like this is vulnerable to TOCTOU or risk conditions. TOCTOU stands for time of check to time of use. Why it is called that, we will come to that. So I'll be abbreviating it as TOCTOU from now on. So when I said that this is looks like this is vulnerable to TOCTOU, most of the people in the room, some of them did not know what TOCTOU is, and some of them said, hey, these type of issues are very rare. It's a risk condition, right? Very hard to occur. Even if it occurs, like whatever controls we have, like a database itself would be able to prevent these type of issues. And I was like, no. And for those people who did not know what was TOCTOU, I had to explain. So say, for example, you are going for a movie and you want your favorite seat. just like you always do, you will book the ticket online. So you are going to the website, ticket booking website, and you select your favorite seat, and then you proceed to book. And the problem with that is that, say, you want your favorite seat and you check whether it is available or not. So once you select that and it says it is available, then you need to complete the checkout process, which involves entering your name, contact information, then entering your credit card information. Then you will go to the final checkout screen. There you click on the final checkout button, and you may get if you're lucky, you'll get that seat. But what if somebody else booked that particular seat before you did? So there is a time gap between the first availability check when you try to see when the seat is available or not, if the seat is available or not, then the actual final booking. So within that time, someone else can actually book the ticket if they are really fast enough, or if maybe if they were the seat was not locked and somebody else was also in the checkout procedure. So these type of issues may feel as just an inconvenience, but it can turn into security issues. So let's talk about that. So what if, so you have another party who booked the ticket before you, and that because of that, you got an error message saying that the ticket is or seat is not available anymore. So what if both of you click on the final book now button together at the same time? It's very unlikely to happen, but imagine that if that happened. Or they clicked on a different time, but because of the network issues or like a network latency or something, it reached at the same time to the web app server. And what will happen? Is the application going to prioritize one request over the other? Is it going to say, hey, I will honor this request and I will cancel the other one? Or it's going to say, hey, let's deny both the requests. I don't think businesses will be happy if two people try to book the same ticket and none of them get tickets, and both of them think that they don't have seats, so they'll just go on with their life, and finally the business suffers because that seat remains unbooked. So that should not happen either. And what if both of them get the same ticket for the same show? Like what if the application honor both the requests? And that's what that's what the TOCTOU issue is about. Like, what if two people are able to book the same property at the same time? So I told them to the team, and of course they did not believe me. They said it is not possible. There are database checks to prevent that, and it is very unlikely to happen. Or they said, hey, the application knows this type of things, so the programming language or the framework will take care of this by randomly selecting one, like a lottery system. But we haven't actually written any code to do that, right? To randomly select one of the requests. So I'm sure that won't happen. And people all said it's a corner case, hard to exploit and everything. There is also a misconception that TOCTOU issues or race conditions only affect money transfer kind of scenarios, because there are many tutorials out there explaining about the same thing. So I over the next days, I came across multiple such situations. I wanted to shout out to the world that, hey, race conditions or TOCTOU issues are real, but there were a bunch of tutorials out there, a bunch of bug bounties out there, but that was not enough. That was essentially only covering money transfer kind of scenarios. And I wanted something to prove them wrong. I wanted to prove that TOCTOU issues are real in web applications. That's why I came up with this project called TimeGap Theory. Now it is OWASP TimeGap Theory, since it is coming under OWASP's umbrella. it's a CTF style application. It's free, open source. So since it is a CTF style vulnerable application, you like there are 7 challenges now. So you get points for completing each challenge. So when you complete each challenge, you learn something about, hey, these are the type of scenarios, and these are the tools you can use and everything. It is Dockerized. You can run it locally on your Docker instance, or it is on Heroku as well. So if you don't want to set up a local machine, you can go to our GitHub repo and click on deploy to Heroku, and you will be having a Heroku instance. And Heroku normally do not charge for running one instance. So basically, you can run an online instance of TimeGap Theory for free. It supports dark mode and snow mode. I'll give you. I'll talk about that later. Bullet time feature is a very interesting feature. That is something that keeps TimeGap Theory unique, and I will give you an intro about that as well. So this is how the home page of OWASP TimeGap Theory looks like. You can see that there are a bunch of buttons here and there: settings, score, web app, and all. The score page is where you can see the scores. So like I said, there are 7 challenges. As you complete them, you will get points for completing them. This is the web app page. This is what is in scope. So you are not supposed to test the settings page or any other pages in the application. All the challenges are in the web app subdirectory. In the settings page, there are 3 inputs: main weight, mask weight, and maximum logins. And maximum logins is a brute force prevention mechanism. You can say, hey, there's a login page in the TimeGap Theory, and how many times user can try like a wrong username password combination before their account's locked out. But the main weight and the mask weight are about the bullet time feature I previously mentioned. So when you say like 3, it's in seconds. So when you say main weight is 3 seconds, the application will wait 3 seconds before making any write operations to the database. This helps us to understand, hey, like how can we exploit TOCTOU issues in like a. It helps us to examine what is happening behind the applications. It is just for learning purpose. In real life, it's very hard to achieve something like that in a regular application. You deal with it like a. If the website administrator is a friend of yours, yes, they can implement this type of feature so that you can exploit it. But it is not practical in real life. It is practical in some cases. Say, for example, somebody is launching a DDoS attack against an application, and at that time, the application will be crawling like a very slowly. Database operations will be slow. Database and application would be loading in a very slow manner. At that time, you get something similar. But you don't want to do that. You don't want to throttle the application before finding and exploiting TOCTOU issues, right? That won't scale. So yeah, for just this is just for the understanding purpose. All right, let me, yeah. Before I continue with the rest of the session, does anybody have any questions about the things we have covered till now? All right, so we will move on to the next part. All right, so this is the sign up page. So this is the first challenge in TimeGap Theory. I'll walk you through the challenge. So you can see that there is a sign up. When you sign up, you have to provide a username, password, email, and there are 4 buttons on top. What those buttons does is that, like But if you click on the Tom button, it will automatically fill the form with the user details of Tom. So name would be Tom, password would be Tom, email would be tom@timegaptheory.com. Why it is to ease things up. So when you are learning about TOCTOU issues or race conditions in TimeGap Theory, you don't have to actually fill the form all the time. You can save that time by clicking on each button. So this is the sign up page. So this is going to be the high level flow. So the user enters their email address, password. In TimeGap Theory's case, there is username as well, but usually it can vary. So we are looking at a general flow. So when somebody enters their email address, username, password, and email address, then they click on sign up button. When they does that, the application will check the database to see if the user is already on the database or not. If they find a user with the same email address or username on the database, it will say, hey, it may show an error, it may not show an error. It will say you can't create this user account, maybe change the username or choose a different email, something like that. If a match is not found, if there is no previous record of that particular username or email address, it will say, it will create a new account and it will tell that to the user that, hey, we have created a user account for you. So that is the regular flow for any sign up page out there. So this is again the same thing we have discussed in a graphical format. So the user, or we have the user on the left-hand side, they enter email and password. The application in TimeGap Theory, it is a PHP code. So PHP will check, PHP application will check this if the email access on the database or not. If not, it will create an account. Now the same thing in a sequence diagram, and we see what exactly happens time-wise from top to bottom. So the first action, second action, etc. And we are looking at 2 people trying to sign up for the account at the same time. So I'm sure that 2 people wouldn't be able, like if it is 2 people, they wouldn't be attempting to create a new user account with the same email and password. But think of it as an attacker. So I'm the attacker, and I know that I want to sign up for an account in a particular website. And when I do that, I submit 2 requests at the same time. I use the same email address and password, or same username and password. Then I try to sign up for the account. And both the requests reach to the application at the same time. Application checks the database to see if the email access or username access on the database or not. Since it is not there before, the database will say, hey, this email address or username does not exist on the database. So application will say, hey, create this particular account, 2 times. So we will end up having 2 user accounts on the application with the same username and password, or same email address and password. So we will see whether that works or not. So this is us trying to do that. So I'm resetting the database. It's a good practice when you work in TimeGap Theory to reset the database for time to time to make sure that the slate is clear. So then I clicked on Tom button to fill the form with the user details of Tom. Like I said, it will fill Tom, password would be Tom, email would be tom@timegaptheory.com. And clicking on the submit, and I'm doing it again, but this time I'm getting an account email address already exists message. That is because there was a time gap between the when I submitted the form first and the second time. So we need to change that. So how can we send 2 requests together is the question. First, we will use the bullet time feature. So Okay, so we are going to settings, and we are going to change the delay a little so that there will be a write operation delay across the application. So we are changing that to value 5. So the application will wait 5 seconds before each write operation. We updated that. Then we are going to the sign up page. Then we are filling the details for Jerry this time, a different user. Then we are opening up a different browser and going to the sign up page there as well. And there we will again click the user Jerry. So, sorry. Okay, so in both the browsers, there are users, user details for Jerry. Then we click on submit button on both browsers as fast as we can. Both the pages are loading up. First page load, second page loaded. Okay, looks like the requests are successful. If you go to admin and manage users, you can see that there are 2 users with the same email address and first name. What are the implications of that? The user would be getting a backdoor. Say when you look in TimeGap theory, each user gets a joining reward points of 100. So since this user signed up for 2 accounts, they get total 200 reward points. Or it can it is based on the application, how the application is designed. You may get more reward points. You may get a permanent backdoor to the system, etc. If you go to the score section, you can see that you have gained points for completing the sign up challenge. So this is using bullet time. In real life, you can't use that. So what can we do in real life? What are the tools we can use? First, we are going to use browser dev tools. So I'm clearing the database. I'm going to the score page. Yeah, score is cleared. And then I'm going to sign up page. I'm clicking on Tom. Then I click on the submit. Yeah, it is showing that email address already exists. So we are going to inspect. This will open up Chrome DevTools. If you're using Firefox, Firefox also has DevTools. Most modern browsers has DevTools these days. Then you, sorry. Yeah. Then you go to Network tab, click on the Submit button again, and you will have the signup.php page. Right click on it and copy it as fetch. Then you go to the Console tab, you paste it, and the request will be having details of that particular user. So I'm changing that to DevTools for making sure that it is visible. And I'm copying that particular request, pasting it again. Then so we have 2 requests now. I'm submitting it to the application. Okay, it is submitted. And we will go to manage users, and we have 2 users this time. So this is one of the tools you can use to find and exploit TOCTOU issues, browser dev tools. It's easy, and for doing this, you don't need that bullet time feature. So you can do this in real applications. There is one more method. It is by using curl. Here, what we will do is that instead of copying that particular request from browser dev tools as a fetch request, we will copy it as a curl request. Since it is a curl request, you need to have a terminal or command line to execute it. So yeah, I'm changing. I'm trimming it down. You don't need the complete request. There are a bunch of junk data there. You can remove that. What is important is that URL and the request data. Then if you are on Mac or Linux, you copy paste the same curl request, separate it by a space and an ampersand sign. If you are on Windows, it is slightly different. I will show you that as well. I'm copying it. I'll go to my terminal and I'll paste it. And it looks like it is successful. If you go to manage users page and refresh it, there you have 2 users with the same username and password. And now you know how to solve a sign up page challenge using bullet time feature, using browser dev tools, using curl. Now we will see an actual tool for exploiting race conditions. It is called Race the Web. It's developed by Aaron Nato, who was a former colleague of mine. It's a wonderful tool. One thing I love about this tool is that it integrates into CI/CD pipeline pretty well, so it can really help you in organizations. So again, we are clearing everything, even the score, to make sure that our slate is clear. I'm resetting the database and everything. And what we do is that this is how the request would look like. So for Raise the Web tool to work, you can get the Raise the Web tool from GitHub for free. It is written in Go language. Either you can download it and compile yourself, or binaries are available as well in the distribution release tab when you go there. And Raise the Web tool needs to be configured before running. And this is a sample TOML file. It accepts TOML files. So you can see here that the count is 10 on line number 3, which says that, hey, this Raise the Web tool should send 10 parallel requests to the application. We are turning the verbosity off. We don't have to see much more information. Then we will separate each request. So we have only one request. So we'll call it with request. The method needs to be paused. This is going to be the URL, and this is going to be the request body, how request body should be. Then we call Raise the Web tool and supply this particular TOML file. Click the enter button, and it will do that for you. Then you go back to the application and refresh the page, and you see that, hey, I was able to create 3 user accounts with the same email address and password. So now you know how to find and exploit TOCTOU or race conditions using tools, or just using browser, or using curl. Yeah, then let me check. Okay, I will share some more stories. So there are 6 more challenges like that. I'm not going to the details of that, but I'll share some interesting stories about race conditions. All right. So there was people used to believe that PHP is immune to TOCTOU issues or race conditions, because PHP in itself can't handle concurrent requests. So people used to think that, hey, if you are developing a PHP application, you don't have to worry about TOCTOU issues. I wanted to change that. When I started developing TimeGap Theory, my effort was to prove to the world that, hey, TOCTOU issues can happen in real world. But then I heard about this thing and I rewrote the application. So I developed initially, I developed it in Node.js initially using express.js. And then I was like, no, then people may come back and say, hey, all these looks good, but I'm developing a PHP application, so it wouldn't be vulnerable to TOCTOU or race conditions. So I rewrote the application PHP to prove them wrong. PHP is vulnerable as well. It is not a you can't say it is a fault with PHP. PHP usually runs on some server, say like an Apache, and they supports concurrency. And because of that, PHP also inherits TOCTOU issues. So if you are developing a PHP application, yes, there is avenue for race conditions or TOCTOU issues. Starbucks had TOCTOU issue back in 2015. So there is a blog you can go and visit. So what happened there was that you purchased 2 gift cards from Starbucks, and you can transfer money from one gift card to the another gift card. So when you transfer money from one card to another, first it will check whether the say for example, my first card has so certain amount of money, X amount of money, and second card has Y amount of money. And when I transfer the money, first it will check whether the card has enough balance or not. Then it will, if there is enough balance, then it will transfer the money, right? So there is a time gap between the check and the transfer. So if you basically initiate multiple requests to transfer money from first card to second card, you can make money out of thin air. The application will all the checks will get thumbs up, and you basically get money from Starbucks account to you. We have a similar kind of challenge in TimeGap Theory as well. It is called money transfer. So when you try TimeGap Theory, be sure to check that out. There are lots of bug bounty reports out there. If you Google, people have started finding this type of issues. And the problem is that most of them are focused on money transfer kind of scenarios, because since the day the Starbucks issue came out, people know that that particular issue can happen. So they focus on there, but they focus on they do not focus on any of the other, they completely ignore all the other 6 possibilities or endless possibilities. So if you are a bug bounty hunter, TOCTOU issues are waiting there out for you to be exploited. So maybe TimeGap Theory will help you to learn how to find this type of issues or find the scenarios and help you earn some bounties. Over race conditions or TOCTOU issues were never in OWASP top 10. It was never in SANS top 25 or any those type of lists. But that does not mean you don't have to address this type of issues. As a developer or as a business owner or as a defender, you need to plug all the holes you can, right? As an attacker, it is easy. They necessarily doesn't have to find a security hole within OWASP top 10. They can go beyond OWASP top 10. So it's important to realize the potential of these type of issues and fix them. Like I said, attacker needs just one open door, even if you have closed all of the others. In 1993, at least 3 patients died and several people were injured due to a race condition issue in a radiotherapy system. You can read more about that in the link below. So in healthcare systems or life critical systems, these issues can be really dangerous. So it is important for us to find these type of issues before those type of things happen. The Northeast blackout of 2003, it was a widespread power outage in the US and Canada, was also caused by a race condition bug in one of the power control systems. We have released a book walking you through challenges in TimeGap Theory. It's available in Amazon and everything, but I basically, it's an OWASP project and we did not want to make any money out of it. So the printed book costs you money, but if you go to timegaptheory.com/book.html, if you scroll down, you can get a PDF version of the book for free. I also wrote a poem for TOCTOU issues, but I'm not going to recite that now, considering our time constraints. These are the team members involved in bringing this project out to you today. These are my friends and colleagues who helped me out in reviewing the guide, testing the product and everything. We have been working on this project for 2 years now, and now we got a chance to launch it. Thanks to AppSec Israel for giving us this venue. You can help us too. So maybe a tweet or a blog post or Facebook share or LinkedIn share can help us, because you guys are our like a first audience. So you can help us by spreading the word. If you have questions, we have there are several ways you can contact us. There is a Slack channel in OWASP Slack space, or there is a Reddit. There is a subreddit. So if you can contact us on Reddit as well. We are available on email as well. If you go to timegaptheory.com/contact, you can find that information. And yeah, that would be all from my side. We thank you for attending the session on behalf of all the OWASP TimeGap Theory team members. Over to questions.
Okay, you can raise questions using the Q&A chat. Please feel free to do so. In the meanwhile, Abhi, I do want to ask a question myself. You just show us how easy it is to launch such race condition attacks using curl or DevTools. But what I want to check is there any way to automate such attacks instead, not just using scripts?
Automating, yes. The last tool I mentioned, Raise the Web, is the perfect tool for that. It allows you to make lots of TOML files and just feed it, and you can automate it. It is just for just the exploitation part, though. Like if finding it, it needs manual effort. That's why it is not being that much detected. But I'm keeping an eye on that as well. I'm trying to see, like, as more people start using TimeGap Theory, maybe we will get more ideas about how to automate these type of things. So sadly, most pen testers do not test for these type of issues, since it is very hard to test. Most scanners out there, SAST or DAS scanners, also do not detect these type of issues. So it's very hard to find this type of issues. That's why that's why it is important for us to learn, because if you're a bug bounty hunter, like almost all the applications out there, they passed through scanners, but they don't have, they did not check particularly for this issue. So maybe these type of issues are waiting for somebody to find out, or since people, when people say like you want to safeguard your application against this type of issues, so you can use these tools and test it yourself. Hopefully we will tools and everything will catch up, but for now it's mainly manual effort. Thanks for the question, Nisa. Yeah,
sure. I even have another one if you ask it. Okay, so let's say that in case that as a security consultant, what are the best ways to mitigate or remediate such vulnerabilities?
That's a great question. So there is a session. I'll give you the link to that. There has been a session in HackFest in Canada, focusing on that. There are various methods. One of the method is to use logs. So when you use logs, say for example somebody is trying to book a ticket, or say when somebody is trying to, say like the movie tickets example, let's take that. So you are trying to, one user is trying to book the ticket. The application will log that particular seed for X minutes. It can be 15 minutes or something. And within that time, if once that time elapses, the seat will be opened up for everybody else. So till that time, it is reserved to you. You can complete the checkout process within that time, and you will get the ticket. Nobody else will get the ticket. So something of that sort. But what I found was that locks are like you need to be really careful in designing locks. So when you say, hey, we will lock that seat for 15 minutes, attackers can find that as an opportunity. They can keep on trying to book all the tickets in the show, and they will do that, and they will refresh that page, or they will log out and do it again and again every 5 minutes or 10 minutes. And all the seats will be locked and nobody would be able to book those tickets. So you need to, and there is a mechanism called, there is an issue called deadlocks. So if you don't design the locks carefully, two threads of the same application or different applications can try to lock the same variable or same entry, and that can lead to indefinite locks or stability issues. But with a careful design, these type of things can be prevented. So locks, and some databases also have started coming up with some solutions. So let's say, for example, in database, you can mark some parameters are unique and on those type of things. And databases allow these type of things. So like application doesn't have to like before doing the write operation, it can do the checking right there. So checking, so the time of check to time of use, that window will get narrow if it happens in the same call. So when you book the final ticket, it will do the check again and then book it. So those type of things can prevent these type of issues.
Okay, thank you. If you don't have another Q&A from someone, we'll give you last chance. Okay. So,
I just wanted to say that I'm really thankful to AppSec Israel for giving us this chance. This is our this is our premiere right after Global AppSec. So thanks to you guys and for all the attendees.
Great. So Abhi, thank you for dedicating the time and effort to conduct this session. And that's it. Thank you very much.
Thank you. Bye, everyone.
Bye-bye.